Hello dear student. In the fourth session of the lesson Structure of the Atom, we're going to talk about the following objectives. Define monoatomic ions. Find the charge of monoatomic ions after calculating the charge of its nucleus and of its electronic cloud. Represent an ion by its symbol by mentioning Za and the charge, and determine the composition of an ion. Watch the video to figure out the definition of an ion.
Ions. An ion is a charged particle. It is charged because it contains an unequal number of protons and electrons. So an ion is an atom that has either lost or gained electrons. There are two types of ions, cations and anions. All atoms have neutral charge because they have an equal amount of protons and electrons. But when an atom loses one or more electrons, it becomes a positively charged ion. And this type of ions are called cations. But when an atom gains one or more electrons, it becomes a negatively charged ion. And this type of ions are called anions. Were you paying attention? Answer these two questions and find out. Question number 1. Define an ion. Question number 2. Name and explain the two types of ions.
So after watching the video, we can infer that the definition of an ion, it is a charged entity formed due to a loss, like the one shown in the figure, or a gain of electrons. So here we have loss of electrons, Na changes into Na+, and when we have gain of electron, Cl changes into Cl- ion. Why are ions charged? Because in a neutral atom, the number of electrons is equal to the number of protons. However, after this atom has gained or lost electrons, the number of protons is no more equal to the number of electrons. So, in the following application, we have a figure representing neutral lithium atom. As you can see, it has 3 protons and also 3 electrons. However, Li can lose 1 electron to become an ion. So how to find the composition of lithium ion? The composition of lithium ion, it is the number of protons is equal to 3 because we don't have a change in the number of protons. Concerning the number of electrons, after losing 1 electron, as you can see in the figure, the number of electrons become 2 because 3 minus 1 is equal to 2. Concerning the number of neutrons, it remains the same for the neutrons. The types of ions. We have 2 types of ions, cation and anion. The cation is positive and the anion, which is negative. Now, why is the cation positive and the anion negative? In fact, cations are those atoms that lost their electrons. Therefore, after losing electrons, the number of electrons will be less than the number of protons. Because the positive particles are more than the negative ones, we see that the cation it is positive. Anions are atoms that gained electrons. So after gaining electrons, the electrons will be more than the number of protons. The negative particles being more than the positive particles will make the anion negatively charged. The atomic number Z. We know that the atomic number Z is equal to the number of protons. Because the ion and the atom, they have the same number of protons, so the atomic number Z for an atom and ion is the same. The adjacent figure, for example, represents lithium ion. How can we find the atomic number Z of lithium ion? Simply we count the number of protons, they are 3, so Z is equal to 3. The mass number A. Also by referring to the rule, it is the total number of protons and the neutrons, which are called the nucleons. Because we don't have a change in the number of protons and the neutrons, the mass number A is the same for an atom and an ion. How much is the mass number A of lithium ion? We add the number of neutrons, which is 4, to Z, which is 3, the answer is 7. So as a conclusion, the number of protons in an atom and ion, it's equal. The number of neutrons, it's also equal. The atomic number Z is equal because they have the same number of protons. And the mass number A, it's equal to Z plus N in both cases, so also it's equal. The difference is only in the number of electrons and the charge. In the atom, the number of electrons is equal to the number of protons because the atom is neutral. In case of cation, it is the number of protons minus the number of electrons lost. And in case of anion, it's the number of protons plus the number of electrons gained. So, as a result, the charge of the atom is neutral. That means 0. The charge of the cation is positive, and the charge of the anion is negative. What about the nuclear charge of an ion? We follow the same rule for the atom and ion. For example, if we want to calculate the nuclear charge of the lithium ion represented in the figure, we write the rule and then we find out the number of protons. It's 3 times 1 plus and 4 times 0. The answer is 3 plus. So the nuclear charge does not differ between an atom and ion. The electronic cloud charge. Also we follow the same rule. However, the number of electrons differs between an atom and an ion. So in the following application, the number of electrons is 2 in the lithium ion because it has lost 1 electron. By following the rule, we get that the charge of the electronic cloud is 2 minus. To find out the charge of the ion, we simply add the charge of the nucleus with the charge of the electron cloud. Therefore, if we want to find the charge of lithium ion, we add the charge of the nucleus calculated before with the charge of the electronic cloud to get the answer that is 1 plus. So notice that here the charge of the ion could never be 0 because the ion is not neutral. The nuclear representation of a cation. It is the same as the representation of an atom in addition to the charge of the ion added to the upper right. So the symbol of the atom, which is XAZ, we add to it in case of cation N+, where N is the number of electrons lost. Concerning the anion, the same rule, however we write N minus to the upper right, where N it is the number of electrons gained. So, in order to symbolize lithium ion, having Z equals 3, A equals 7, and its charge 1 plus, simply we write the symbol of the ion, that is Li, Z represented to the lower left and A represented to the upper left, and the charge that is 1 plus is represented to the upper right. Equation of ion formation. These are some examples for equations of ion formation. However, how can we write such equations? Step 1, we draw an arrow. Step 2, we write the symbol of the atom before the arrow and the symbol of the ion after the arrow, because it is the equation of ion formation. So the ion that is formed, we write it after the arrow and the atom before the arrow. But what about the number of electrons? Concerning the number of electrons, it differs between a cation and an anion. We start with a cation. In case of cation, the number of electrons is written after the arrow, and that's because the electrons are lost by the atom. So, N, it is the number of electrons lost. We have loss of electron, the cation it's positive, and the electrons are written after the arrow. So if we want to write the equation of ion formation of aluminum, Al, that has lost the 3 electrons, we write the symbol of the atom before the arrow, the symbol of the ion after the arrow, and the 3 electrons that are lost after the arrow. Concerning an anion, the electrons are written before the arrow. As you can see in the rule, they are written before the arrow. N is the number of electrons gained by the atom in order to change and become an anion. So the anion gain electrons, it is negatively charged, and the electrons are written before the arrow. So an example how to write an equation of ion formation for oxygen atom O that has gained 2 electrons. We draw the arrow, O before the arrow, and the ion, which is O2 minus after the arrow. It is negatively charged because it has gained, and 2 minus because it has gained 2 electrons. The electrons are written before the arrow. As an assignment, you have to solve extra sheet 3.